Okay, my lovelies, let's do a couple examples of orbital notation, orbital diagramming. And to make it a little bit easier, we're going to start with the electron configuration first and just see that connection to the orbital diagram. So we're in our first example, we're going to do carbon. So remember in electron configuration, we always start at the beginning here. So we're going to start at the lowest energy level first. And when we go through, we start at that lowest energy level. So we have 1s2 here. And we haven't found carbon yet, so we go to our second energy level, 2s2. Haven't found carbon yet, and then we have 2p2. So when we're doing that orbital notation, orbital diagramming, we're going to go ahead and put our boxes. Remember we said S gets one box. And then we have another S, so it gets one box. And I personally think it's easier to go ahead and draw the boxes above your electron configuration. And remember, P gets 3 boxes. Let's draw our 3 sections in our rectangle. Okay, so I have these 2 electrons, and so I'm going to start on my lowest energy level first, and I'm going to show opposite spin by drawing my arrows go opposite directions. So remember that one rule that says the electrons must spin opposite directions? I'm going to show that. Spin opposite directions. And I'm going to show that by doing an up arrow and a down arrow. That's that opposite directions. And then we have 2 electrons here, so we must spin opposite directions. Notice I don't have more than 2 arrows in a box because our max of 2 electrons. So side note, an arrow is representing an electron here. So that electron is that arrow. Now we have 2 electrons here in this P. Now this is where that one rule, it states that every orbital gets an electron before getting 2. So that means every rectangle here gets an electron before it gets 2. So I have 2 up arrows. Notice I'm leaving this box here empty because I don't have enough electrons. Notice that each box here is getting an individual arrow because that second rule, every orbital gets an electron before getting 2. So let's do another example. Okay, so sulfur. So we start at the beginning, 1s2, go through that whole row, go to the second row, 2s2, still haven't found good old sulfur, go through the row, still haven't found sulfur yet, so 2p6, still haven't found sulfur yet, 3s2, still no sulfur, 3p, 1, 2, 3, 4. Remember, our boxes represent our electrons. So when we're doing our orbital diagramming here, S gets a box, S gets a box, P gets 3, S gets a box, and P gets 3. So I have 2 electrons, start at the lowest energy level first, no more than 2 electrons in an orbital, and they must spin opposite directions. Okay, again, 2 more electrons in the S, max of 2 electrons, and they're spinning opposite directions. In this one I have 6, but every orbital gets an electron before they get their second electron. Okay, so everyone gets an electron before getting their second electron. S can't have more than 2. And then in this one, everyone gets an electron. So that's 3, but I technically have 4 electrons. So I will have 1 down arrow there. Your number of arrows equal electrons. So again, your arrows represent electrons. Your superscripts are your electrons. Let's do a quick review of valence electrons here. So this is my highest occupied energy level. That's a little thick there. So the third energy level is my highest occupied energy level. Highest or outermost. So the electrons that exist there are our valence electrons. So this right here are my valence electrons. So you can see that I have 1, 2, 3, 4, 5, 6 arrows here. 6 valence electrons in sulfur. Now let me give you a couple of hints. So instead of trying to memorize that S gets 1 box, we know that we can have no more than 2 arrows. So if you go into this S area, on any given row, how many boxes are there in S? So hydrogen, helium, that's 2. Lithium, beryllium, that's 2. Sodium and magnesium, that's 2. Rubidium and strontium, that's 2. 2 arrows divided by 2 means I get 1 box. Okay, how many boxes are there in P? 1, 2, 3, 4, 5, 6. Notice I can have no more than 6 arrows. Coincidentally matches those boxes. If in each box I can have 2, 6 divided by 2 means I have 3 orbitals. In D, you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 boxes on the periodic table in the D area, which means if I can have no more than 2 electrons in each orbital, 10 divided by 2 is 5. So I'm going to draw 5 boxes when I do D. On that note, let's go ahead and do an example with the D block. So let's go ahead and do. I want to do. Let's do titanium. Okay, so we're going to do titanium. So we start at the first energy level here, and we go through until we get to titanium. So we have, I'll give myself some room here, 1s2, and I have 2s2, then go all the way through here, and I have 2p6, 3s2, 3p6, and all I'm doing is going through, counting 1, 2, 3, 4, 5, 6. Still haven't found good old titanium. 4s2. I'm going to run out of room. And then now I'm in my D. Remember, D goes down an energy level, so it is 3d2. To do my orbital notation, I'm going to need some space here. So 1 box for S, 1 box for S, 3 orbitals for P, 1 for S, 3 for P, 1 for S, and then how many do I have for D? Remember, you can always count across and divide by 2. 1, 2, 3, 4, 5. 5 for D. And let's put our arrows in. So I have 2 electrons, so 2 arrows. I have 2 electrons, so 2 arrows. 6 electrons, everyone gets an orbital, gets an electron before they get 2. I have 2 electrons. 6, everyone gets an electron before they get 2. 2 electrons. And then I have 2. Remember, every orbital gets an electron before they get 2. So I don't put both arrows in one box. I don't just draw one box. I'm going to have all 5 boxes there so that I see have some empty orbital shapes for D. So if we were to talk about valence electrons on this one, remember our highest or outermost energy level is 4. Because we go down for 3, so there's only 2 valence electrons in this. I want to do one last example. Let's go to P. One last example today. Reserve my space here, kids. So for this one, I'm going to actually write it underneath. Actually, it doesn't help going underneath. Let's try and make this a little bit smaller here. Okay, so for this one, let's do you can't see it, but arsenic is right here. So we're going to do arsenic. Start at the beginning. 1s2. 2s2. 2p6. 3s2. 3p6. 4s2. Going to go through all the D's because I still haven't found arsenic. So that's going to be 3d10. And then come back up for P3. Oh, is it undo? Undo. There we go. Sorry about that. 3p3. Okay, so let's do that orbital notation. So remember, for S, draw one box. For S, draw one box. For P, we'll draw 3 boxes. S, 1 box. P, S, D, and then P. So 2 electrons, 2 electrons, 6, so everyone gets 1. Then they get 2. 2 electrons, and you can do a half arrow instead of a full arrow if you like. 6 electrons, everyone gets an electron before they get 2. 2 electrons, D. Everyone gets an electron before they get 2. 1, 2, 3, 4, 5. And then I have 3. Everyone gets an electron. If we're talking about valence electrons, the 4th is our outermost. So I have this 4, but I also have this 4. So both are the outermost. So the D goes down in energy level, but it goes back up when it goes to the P section. So I have 2 plus this 3, or you can count your arrows. So you end up with 5 valence electrons.